All right, section 12.6 is over rational expressions with like denominators. That's an important word here because the next video or the next set of videos, hopefully there's only one today, are going to have unlike denominators. So we need to first talk about how do we add fractions that have like denominators. Remember when you first learned, I didn't teach you fractions first. When you first learned fractions, you said the first observation is that you have thirds, so that you are going to keep the denominator and you're simply going to add the numerator. So we would do 2 plus 7 so that we would get 9 thirds as our answer. And if we could simplify, we would. So we would say that 9 would become 3 times 3 over 3. Notice I'm prepping us for our next step so that we get an answer of 3. Now, I am fully aware that you could just look at this problem, this nice, basic, easy problem, and have an answer. But remember all the steps that we did here. We kept the denominator because it was the same. And we added across. Then we simplified. And as part of my simplifying, remember I did my factoring as part of my simplifying. That's why I did that. So the first version is, as always, nice and easy. Do we have the same denominator? Yes. We keep it and we add across. So 3x plus 4x. Those are like terms, so they can be combined. So we get 7x over 5. And can we simplify our fraction? Nope, not this time. Why don't you go ahead and work through number 2? Actually, I'm going to leave number 2 for you to work through, but I want to go ahead and talk about number 3 now so that you can also work through 2 and 4 at the same time. So let's work through number 3 next. The first observation is, are they like denominators? Yes, they are. So we don't have a pre-step. We can just keep that denominator and we can add across. So y plus 2 plus y plus 4, like terms. So we end up with 2y plus 6 all over 2y. Now be careful, right here, that's a quantity, so that if I'm going to be able to simplify, I have to do a factoring step first. So that's really 2 times y plus 3 over 2y. It's my simplify step. 2 over 2 becomes a 1, so that my answer is just y plus 3 over y. So again, let me recap our steps. We made an observation that we had the same denominator. So we kept it and we added straight across. We combined like terms because that's what that addition is. So we did y plus y to get 2y. 2 plus 4 to get 6. And then I saw that I could undistribute, or I could factor 2y plus 6. So I did. I undistributed the 2 to get y plus 3. The purpose in it being that 2 over 2 becomes a 1, so y plus 3 over y. You are not always going to be able to factor like this. So if it's not pointful, if it doesn't get you the ability to reduce, you do not have to do it. Would you please give problems 2 and 4, actually 2, 4, and 6. 2, 4, 5, and 6. Get them all done. So 2, 4, 5, and 6. Do those 4 problems, come back and check your work. And welcome back. Check over your work. I want you to be really cautious and check number 4 carefully, that you didn't simplify when you can't. And also check number 5 and number 6 very carefully, that you did simplify or undistribute, factor, whatever word you want to use there, when you can. We need to finish our conversation by talking about subtraction. And really, subtraction isn't much different. The only catch to subtraction is, well, it's kind of the obvious, that you have to make sure you distribute the negative. So when we look at number 7, we always start with the same thing. Do we have a like denominator? Yes. So we can keep it, and then we can technically add across. But since it's a negative, we actually have to distribute that negative in order to do this. So x plus 8 stays, but then we distribute the negative. Minus x minus 6. And combining like terms, we get 2 over 4, because x minus x is going to give me a 0. And 8 minus 6 is 2. And finally, finish by simplifying your fraction. 1/2. Let's go ahead and work through, I'll leave number 8 for you. Let's work through number 9. Do I have a like denominator? Yes. Then my first step is to keep it and add or distribute the negative, then add. So the first quantity stays, 5y plus 1. The second quantity, my negative, gets distributed, minus 3y plus 7. Combine like terms. 5y minus 3y is a 2y. 1 plus 7 is an 8. So that we get 2 times y plus 4 over y plus 4. And I can in fact simplify, and I get an answer of just 2, or 2 over 1. Let's do one more together, and then you have some practice problems. In number 10, notice that we have a c squared. So it's going to be a big red flag that our factoring isn't just going to be greatest common factor, but it could also be difference of perfect squares. Or looking ahead to number 11, a factoring, regular factoring problem. Or actually, I guess number 12 would probably be a better place. At any rate, let's do number 10. Do I have a like denominator? Yes. So let's keep it. Then we would distribute that negative. So c squared, in this case, it's just minus 4. And we always try to simplify. Those quantities are not exactly the same, but I can factor that c squared minus 4. Remember, it's a difference of perfect squares. So c plus 2 times c minus 2, because the o and the I of FOIL add to 0, over c plus 2. And then I can simplify so that I get c minus 2 as my answer. Why don't you go ahead and try problems 8, 11, and 12, and then come back and check your work. All right, so you're back and you're checking your work. I want to just point out to you, in number 11, notice that your x squared's added to 0, and then you ended up with just a GCF problem, or a greatest common factor problem. And then also to point out to you that you needed to make sure you distributed that negative to the 12, otherwise this problem wouldn't be factorable. Make sure you use your denominators as a guide to help you remember what you could possibly need to simplify, so that the x minus 4 in the denominator here kind of drives the fact that we needed to use x minus 4 in the numerator when we did our factoring. So use those cues that are built into the questions to help you when you need to. I will see you in our next video or in class so we can talk about unlike denominators next.